So we have practiced using probability of A and B, A or B, or A given B. So just to review it, A or B is when A happen, B happen, or both them happen, right? So the successful outcome are like that. A and B means both quality needs to happen at the same time. A given B means you're changing the sample space to assuming that B has happened because all the others doesn't happen already. So only B has happened. So the sample space is changed. So we are trying to calculate this kind of probability when we are analyzing a two-way table, a contingency table. What is a two-way table? It is something that categorizes a set of data by two ways. So sort of like the one that we talk about. If you look at a student, so we can record his gender and also the class is he or she is taking. Um, so then you can record two quantitative data. No, two categorical data. So for example, you ask a question whether this student has taken statistics or not, or need to take statistics or not, and also the gender. So these are two categorical characteristics of the same subjects. So you can think of the first students is female, answer the question yes. The second is female, answer no. And then also female, answer no. You see what I mean? So these are the raw data. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 subjects. Oh, there's a lot of males, and these are the answer for that question. It could be any question that you want to ask. So we summarize it into a two-way table. Remember, two categorical. So by listing the yes, no in the column, and then the female, male in a row. So if it is a female and answer yes, we say 1. So there's a female answer yes over here. Female answer no, we have 2. Okay. Male answer yes, we have 3. These are all 3 males, they answer yes. And we have 4 females that answer no. So basically, this is a summary of two categorical data. So if I look at this number 3, this cell, that means there's 3 counts of subjects that answer yes as well as a male. Okay. So the one that is easy to see would be if I want to find probability of females, so I would use the total count. So grand total, we always do the grand total of 1 plus 2 plus 3 plus 4, add all the cells together. In this case is 10, right? Grand total is 10. And then for probability of a female, F means female, this is all the female. If you look across, it's 1 plus 2. That means I don't care what answer they have, they're all female. So you look at the original data, it is 3, right? So I do 1 plus 3 is the whole row or whole column. If I say, what is probability I pick someone that answered no? So you would look at no in this we don't care what gender they have. So there's 2 female, 4 male, but all these answer no. So it will be 2 plus 4, 6. 6 divided by 10 is 0.6. So this is the old stuff. You only look at one characteristics. What about if I say male and no? That would just be one cell, right? Because and means it has to be male as well as no. So male and no would be the cell that has the no and the male. So it will be 4 in the numerator, and then the bottom denominator is the sample space that is everyone. Because you can pick anyone here, but only this 4% is male and answer no, right? And answer no. So let's try female and Y. Female is this, and yes, it's just one person, right? This is the only one that is female and answer yes. So 1 over 10. Let's practice OR. OR means either one, right? Either they are female or answer yes. So what I'll do is I will look at all the female first because they say a female. So that will be 1 plus 2. And I also will need to, so it's okay to also include those that say yes. Well, what other people would say yes? So what happened is we would say, well, these are female, but this column are subjects that say yes also. So I just want or. So all of these three counts or these three cells will consist of people of F or yes. So it is 1 plus 2 plus 3. 1 plus 2 plus 3. Because they satisfy this requirement. Or means to get they are both, or just female, or just yes. Right? Or means a lot. Okay, so I'm going to erase it so we don't get confused. Move on to the next one. They say male or yes. Male. Male is this or this. I circle all the male. And then I want yes. Yes is this column. So I don't double count this 2 times. I would just say 1 plus 3 plus 4. Right? I do 3 and 4 and then a 1. So that would be the outcome that will satisfy both satisfy either M or Y. So that would be 8 over 10 is 0.8. Let's practice the given. So what is the probability that the subjects will answer yes? Given is a male. Maybe I know that that's the one that I'm interviewing is a male. So I would look across, right? Look across just this. I would concentrate. I'm going to erase this. So I will concentrate my attention, change the sample space. Remember when we do given or conditional, you change your sample space to only males. How many males are there? It's just these two, right? So you would just look at this. This is your sample space 7. And then you only want to have all these male that answer yes. So look at the column. Which one go yes? This is the one, right? So 3 people in the male would do yes. So it would be 3 out of 7. Okay. Yes, given is a male. Now let's reverse it. Male given it is yes. That means I already know someone answer yes. I just don't know what is the chance that that is a male or female. Maybe you are maybe you're looking at a survey. You don't see that person, but you look at that survey and you see that person say yes. You wonder if that person could be a male. So what you do, did I say male? Yeah, it could be male. So you would look at this is the given. You always look at this being the sample space. So the yes would be, you only look at this column. You just don't care about the whole contingency table. You say this is given, already happened. So your sample space is only 4 chances, 4 chances. And I wanted out of these 4 chances, how many is a male? Oh, 3 of them are male, right? 3 of them are male. So it will be 3 out of all the yes is 4. So it's 0.75. That means if you know someone is answering yes, the chance that that is a male is 75%. Okay, so you can see that there are difference. Yes given male and male given yes are different. The next things I want to talk about is some terms that we come across. I think now that we have COVID-19 and also people are testing for if they have catch COVID. People are more into what is clinical test, diagnostic test. So there is before that we also had a drug test where if you are athlete, you are competing like I think the more important uh, competition, they would require you randomly. They will pick some uh, athletes to test for drugs. Okay, so, or if you're applying for jobs, sometimes you are required to take drug tests also. They want to see if you take drugs. So not all drug tests are accurate. And also before you take the drug test, if your body were exposed to other chemicals, it might obscure the accuracy of the test. So we can have cases where a person used drugs, but when they do tests, um, they don't test positive, they test negative. Okay, so somebody use drugs, they could test positive. That is correct. They should test positive, but they could test negative, and this is a false negative. So false negative means they have a negative result, but they actually use drugs. Okay. The other case you does not use drugs. Well, then you should not test positive, but you should test a negative. But then sometimes you do have false positive. So these two are wrong. The false negative is you get a negative result, but actually you did not use drugs. The false positive is you have gotten a positive result, but actually you does not use drugs. Okay, so false positive, false negative. In COVID, it could be so this would be a COVID test, right? So you can get a positive result back. And if you do have the disease, you do have COVID, that is a correct diagnostic. But you doesn't have the disease, you just have positive results. So you are it's like a false alarm. So that's called false positive. That is not a big deal because you would just be end up being forced into quarantine, right? But if you get a negative result and you have the disease, it's a false negative, that is very dangerous because you don't know that you have it and you'll be walking around. Whereas if you get a negative result, but you really do not have a disease, that's correct. So yeah, this is how you can interpret those terms. So we can use, you can say that these are two-way table, and you can use these examples to calculate given that, and also or and probability. So let's do one with a given that. So probability that someone is test positive. Positive would be all the positive cases that you have, right? 10 plus 4 over the grand total. In this case, it's 10 plus 8 plus 4 plus 400 is 422. So uh, so someone administer a test, you can think you will sit there. How many chance would I get a positive result back? That would be 14 out of 44, 22. Now, if you are someone that actually taking the test yourself, you know whether you have taken drugs. So let's assume that that person has taken drugs, and then he will look at this probably to say, oh, getting a positive test result is so low. This is really unlikely. Maybe I'll just take it because there's very low chance of getting it. So look at what happened with this result of these drugs is if you already know yourself has taken drugs, so subject uses drugs. So this would be a given that situation. Remember when you do a given that probability, you only look at the whatever row or column that this happened, right? So uses drugs is only this, right? You limit your sample space to these. What are the total people that uses drugs? Is 18, right? So it's the sample space change into not the total. And out of this, how many test positive? Positive is 10. So 10 out of 18 is 0.556. So someone has taken drugs, and for the drugs to get a positive result is actually more than 50%. It's not as high as what we want to, but it's certainly not as low as 0.03. So you will get catch quite easily, but not as low as below 5%. So you can see positive and positive given something is different. So that means this drug is useful. There is a higher chance of you getting a positive test result if you actually have taken drugs. So you can interpret it this way. The two wrong diagnostic would be 4 and 8. They're kind of low. You can actually test what is the error of a positive and an error of a false negative. Okay. So that is all for 3.1 using contingency table to find probability. And in 3.2, we'll use this and or to introduce two new terms called mutually exclusive and independent events.